Hey everybody, it's Mr. Anderson here again for another geometry lesson. Today we're in section 1.3 and we're going to be talking about distance and midpoints. All right, so let's hit the floor running or something. Objectives. First of all, we're going to find the distance between 2 points, both on a number line and in a coordinate plane where you have an x and a y. And then we're going to find the midpoint of a segment again on a number line and also in a coordinate plane where you have an x and a y, and look at a few examples on how you can use some of that information to help solve. Okay? First of all, we want to talk about distance on a number line. Okay, so this is pretty straightforward. This is specifically for a number line. And now when you have something like this on a number line, granted, one way that you can do it is you can just count out how far it is from this point to that point. You can just count it out on the number line a lot of times. Pretty easy. So that's one method that you have. But what will also work all the time, even if you can't count it out, take a look down here. You have either subtract the two x. This isn't x squared. That's like the second x, and this is the first x. So you can take the second x minus the first x. Remember, these bars here mean absolute value, so that means you should take the second x minus the first x and take the absolute value, or you can take the first x and subtract the second one and take the absolute value. It doesn't matter. By taking this absolute value, that means basically it doesn't matter which way we subtract it. Okay, let's take a look at an example and make a little bit more sense. All right, here's our number line. Okay, granted, again, we can just count this out. From Q to R, we could just go 1, 2, 3. Oh, it's 3. Okay, very easy. But let's take a look at our little formula there as well. So if we were going to find QR, and what do we do again? We subtract them. And so I'm going to do -6 minus -3. A little tricky here because minus a negative, remember, if you subtract a negative, what happens? Minus a negative makes it plus a positive. So this is really plus a positive 3. And so what we end up with is a -3. But remember, our formula says we have to take the absolute value of it. So this would end up being 3, which we figured 1, 2, 3 when we counted it. If you did it the opposite way, the same thing would happen. -3 minus a -6 plus a positive. So -3 plus 6 is +3. When you take the absolute value, you also get 3. Okay, easy. All right, one more. Again, same kind of thing, but if we're going to do AX here, remember we're going to take the absolute value and we're going to subtract 2 of them. Doesn't matter which order we do it in. Let's do -5 minus 3. Maybe I should have made that an absolute value bar. -5 minus 3 is -8, and when we take the absolute value, we get +8. Well, if I count this out, what do I get? 1, 2, 3, 4, 5, 6, 7, 8. Ta-da! Okay, pretty easy, right? It's a number line. All right, now this is where it gets a little trickier. Okay, so in a coordinate plane, you might not just have a straight line that with just 2 numbers that you can work with. You're going to have a combination. Remember, in the coordinate plane, you've got an x value for this point and a y value. So this is going to be like, that's your x1, that's your y1, and then out here, this is your x2 out here, and this is your y2 out here. Okay, so you got a number of different things to work with. I don't want to go super in depth on this, but basically, just to give you a quick idea of how they come about this, it's kind of like if you made a triangle here. And remember, this was like your x1, and this was your x2, and this was your y2 up here, and this was your y1. How would you find the distance from here to here? You would just do what? x2 minus x1, right? That would be that distance. What would be the distance from here to here? Well, that's your y1 and your y2. You'd say y2 minus y1. So that's those 2 distances. Well, how do you find this third distance? Do you remember the Pythagorean theorem? A squared plus b squared equals c squared. And so what you do is, and that's where this formula comes from, you're basically just squaring this. that's your a, squaring your b, and it would equal this third side squared, which is the PQ, except then to get rid of it, you have to take the square root. So kind of a little interesting, but that's where it comes from. It comes from right triangles. So the whole thing here, the main thing is you need to remember this formula. You've got the square root of the x's subtracted and then squared plus the y's subtracted and squared. Again, pretty much it doesn't matter which way you subtract these x's, because when you square it, if it comes out negative or positive, either way when you square it, it's going to be positive. And same thing on the y's. Also likely, if you write the y's first and the x's second, in the end you're going to add them together, so it's not really going to matter. So if you don't remember it exactly the way it is right here, that's okay, but just remember you have to subtract the x's, subtract the y's, square them both, and then take the square root. Okay, so let's look at a few examples here. All right, we want to find the distance between these 2 points. Okay, so let's write down our formula here. So first of all, remember our distance is the square root of x2 minus x1, just the second x minus the first x squared, plus y2 minus y1 squared. Okay, so you might want to write that down each time you work out a problem. That way it'll help you kind of remember that. All right, so when you look at this, it doesn't really matter which one you call the first x or the second x. So let's just call this x1, x2, this is going to be y1 and y2. It might help to label it on there so you don't get confused. So let's just start plugging those things in. So we have the square root of x2, which is 3. So 3 minus the first x. Now again, it's minus a negative, so that's going to end up being plus 4. And then the second y is negative 1 minus what? 1. Okay, so we just plug that stuff in. Now we just start working this out. This is going to be the square root of 3 plus 4 is 7 squared. Negative 1 and a negative 1, or negative 1 minus 1, or negative 1 plus a negative 1, however you think of that, is going to be a negative 2 squared. And then when we work this out, what's 7 squared is 49, and negative 2 squared is 4, and then we just add those together, we get the square root of 53. Now, just keep in mind, just briefly, we'll talk about these square root numbers a lot more later, but that is not a perfect square. You can't break that down, and like the square root of 49 is 7, right? 7 times 7 is 49. This is not a perfect square. It's because it doesn't break down perfectly. It's called an irrational number. You might have heard of that before, but if something's irrational, it will not have a decimal that terminates or stops, or it will not have a decimal that continues on forever, or that repeats. I'm sorry, that doesn't terminate or doesn't repeat. The decimal will just continue on forever. For example, a good example of an irrational number is pi. Pi goes on and on forever. Okay? And one more here, just to get a little extra work on this. So again, remember our formula here. Square root of x2 minus x1 squared plus y sub 2 minus y sub 1 squared. All right, let's maybe write in here, this is x1, y1, this is x2, and y sub 2. Let's plug in our points. So this is going to be the second x, so 1 minus, again, a negative, so minus a negative makes it plus, 1 plus 3. Second y is 2 minus 4 squared. So 1 plus 3 is 4, so that's 4 squared. 2 minus 4 is a negative 2. And then when you square these, 4 squared is 16. 2 squared is 4, or negative 2 squared is 4, same thing, which would be a square root of 20. I think later on this year, I can't remember exactly when we talk about this. There is a way to simplify these square roots a little bit, and we'll talk about that, I believe, at some point. For right now, you can probably just leave that in square root form. You could type it into your calculator and get a decimal. Just make sure you round that decimal correctly. Okay. All right, the midpoint of a segment. All right, so first of all, the midpoint of a segment is the point that's exactly halfway between the two endpoints of the segment. And you know, again, on a number line, you can count that out and try to figure out how far each one, you know, the point that's the same distance from both sides. But there is also a nice little formula here that's pretty easy. And remember, again, we just have this number here, whatever it is, that's our first x and our second x. We're not in a coordinate plane, it's back on a number line. So we don't have to worry about y's right now, we just worry about x's. All we have to do is add those two numbers together and divide by 2. That'll give us the midpoint. Okay, pretty easy. The other thing to keep in mind here, before we do an example, that notice here, when you know that something's a midpoint, okay, when you know that something's a midpoint, you know here that AM is going to be equal to MB. So the distance from A to M will equal the distance from M to B. So if you know something is the midpoint, you know these two line segments have to be equal to each other. We're going to use that in a little bit towards the end of the thing today to work out a problem. Okay, so remember that one. Okay, let's do an example finding a midpoint on a number line. Again, you could kind of count it out and figure out how far it is from each one. But remember our little formula. We just add the two x's and divide by 2. All right, so we're finding AC. So A is an endpoint, that's -2. So we're going to go -2 plus C is 6 and divide by 2. Well, what's -2 plus 6? Or in other words, 6 minus 2, it's 4. 4 divided by 2 is 2. So the midpoint of this segment is 2, which is right here. And if that's correct, we should be the same distance from A and C. And if you count 1, 2, 3, 4 to C, and from here 1, 2, 3, 4 to A. It's the same distance to both sides. So therefore, yep, this is our midpoint. Yay. With 2 exclamation points. Good? Okay, that's not bad, right? All right, well, as you can imagine, what we're getting to now is the midpoint formula in a coordinate plane where you have x's and y's. Okay, don't worry, this one's pretty simple too. The only difference here is since we have both x's and y's, if you look at this formula, if you can kind of figure it out, this is what we just did, added the x's and divide by 2. The only difference now is what? We have y's, and so what do? We also add the y's and divide by 2. We just do each part separately, the x's and the y's, and that's going to be the point in the middle here. That'll be our x and y coordinates for that middle point. All right, let's look at an example there. Okay, so in this example, we're going to find the coordinates for the midpoint of GH. G is at 8, -6, and H is at -14, 12. All right, so remember our formulas here. You just add the x's. So we've got x1 plus x2 divided by 2. And we're going to find out what that equals. That's going to be our x. And then we've got the y's. Whoops, that was a little off there, sorry. That will give us our y coordinate. Okay, so again, if it helps you, let's go ahead and mark these. That's going to be, we're going to call that x1 and y1. And we're going to call this x2 and y2. All right, so add the x's. So that means we're going to go 8 plus a -14, all divided by 2. And so 8 plus a -14 would be a -6 divided by 2. And that will give me a -3. And then on the y's, again, we can just do a -6 plus 12. So in other words, 12 minus 6 is 6. Is 6 divided by 2. And so that's going to be a +3. So in the end, when we give our midpoint, remember we write it as an ordered pair. we write the x first, -3 goes first, and +3, the y, goes second. So that would be the coordinates of our midpoint. And if you plotted this on a coordinate plane and drew a line from -6 to -14, 12, you would see that the middle point should be right at 3, -3. Okay, this one's a little bit, we're going to use the same formula, but this is a little differently. If you notice up on the top here, we're trying to find the coordinates not of the midpoint, but of the end point. Okay, so this is a little bit trickier. Basically what's happening here, I'm not going to plot these on a point here, but basically it's like if you've got 2 points, and here's like your middle point, right? That before we knew the end ones and we found the middle one. Well, what we're going to do now in this case, let's see if E is the midpoint. So let's say that's going to be E, and this is D and F. So what we know this time is we know the midpoint, it's -6, 4. And we know that F is -5, -3. This is what we don't know. We don't know what x1 and y1 are. Okay, so it's a little bit different. Before we knew the outside, we knew the outside ones, but we were trying to find the middle. Now we're trying to find one of these end ones. Okay, so we're going to use that same formula, but we're just going to fill stuff in a different area. So remember before how I did this? I said x1 plus x2 divided by 2. Basically, I didn't say this before, but this is like x of the, I'm going to call it x of m, sub m, for x of the midpoint. Okay, that was the formula that we basically used before. I didn't call it x of m, sub m, but that was our answer, right? Well, what I'm going to do is I'm going to just plug everything I can in here, and I'm going to solve for the x that we have left. So x1 is the x that we don't know. That's this one right here. Okay, so that one I'm going to leave as x1 plus, well, what's x2? That's going to be this other side down here, right? So that's -5. And it's going to be divided by 2, which will equal the middle x, or -6. Are you following that? A little tricky, but what we did was instead of plugging in numbers for x1, x2, and then divided by 2 to find this one, we're plugging our numbers in these two spots. Now we just have to use a little algebra to solve for x. And if you remember how that works is if we're dividing by 2, I have to multiply by 2 over 1 so that these 2's cross out, multiply by 2 over here. So now I've got x sub 1 plus a -5 equals a -12 plus 5. And so our x sub 1 would equal -7. Okay, so our x sub 1 is -7. That means that would be the first number there in our ordered pair. I know there's a lot of work on this one. And guess what? Now we do the same thing with the y's. And so before, remember again, y sub 1 plus y sub 2 divided by 2 would equal the y sub m, or the middle y. And so we plug it in. What's our first y? We don't know what that is. So y sub 1. What's our second y? That's this one out here, the outside one, -3. So plus -3 divided by 2 has to equal the y in the middle, which is 4. And now we do algebra to solve this. So times 2 over 1. The 2's cancel. Times 2. So now you have y sub 1 plus a -3, or you could say -3 there, equals 8. And then since this is -3, you do +3. And so it looks like y sub 1 is 11. And so that means that would be 11, -11. So I'm sorry, why did I do negative? +11. And so our midpoint, or our endpoint, would be negative 711. So if you wanted to go back and do the formula the normal way with negative 711 and negative 5, negative 3, it should give you negative 6,4 as your answer. Okay, that was a little difficult, but I think I've got one more, so we can practice that one more time, because that one is a little challenging. So again, just to kind of see what we've got here. We got R, we've got a line, this is S, N is the midpoint. Okay, so it says N is 8, negative 3, S is negative 1, 5. We don't know what this is, so this is our X1 and our Y1. That's what we're going to try to find. That's R. Okay, so again, let's go through here. So remember, X plus X divided by 2 has to equal the middle X. Okay, so X1 we don't know, plus the second X, negative 1. Again, you could just write it as minus 1. That would have to equal 8. Do our algebra to solve this, so times 2, 2 over 1, so these cross, times 2. So what you've got here is X sub 1 minus 1 equals 16, plus 1, X sub 1 is 17. So our X for R would have to be 17. And then we do it one more time with the Y's. Remember, Y1 plus Y2 all divided by 2 equals the Y in the middle. And so our Y1 again is what we're trying to find, Y1 plus 5 all divided by 2 has to equal, this time, negative 3. Let's do our algebra. Times 2 to cross out the 2, times 2 here. So what we have is Y sub 1 plus 5 equals a negative 6. And then lastly, minus 5 minus 5. Y sub 1 equals a negative 11. So this would have to be a negative 11. And that is our answer. Okay, that's kind of a hard one. That's why I put 2 examples in there so you can see it a couple times. You know, again, if you're having a question, go ahead and watch these 2 examples again. All right, moving on. Now, okay, now I like these ones. These are kind of fun. We're going to use algebra to find some measures. So let's look at the problem here. It says, find the measure of PQ. So this is what we're trying to find. That's the measure we're trying to find. But in order to find that, we have to find Y first, right? So how could we solve for Y? We're going to have to write an equation and set it up and then solve it to find Y, and then we can plug Y back into 9Y minus 2 to find the distance from P to Q. All right, so here's the key thing that it's telling us. Q is the midpoint. Remember what I talked about before? I said remember this till the end. We're going to come back and see this again. Midpoint, if this is the midpoint, what does that mean? That PQ has to equal QR. So in other words, from P to Q, that has to equal Q to R. So what we can do is we can just write an equation making this equal to that. So 9y minus 2 has to equal 14 plus 5y. That's our equation. We just wrote an equation. Now we're going to solve it, okay? Algebra. We're going back to algebra now. Remember, first thing I usually like to do is get the y's together. So I'm going to do minus 5y to get these to cross out. If I do minus 5y on that side, I have to do minus 5y on this side. Now, kind of at the same step, you could do these in separate steps, but since I got the y's together here, I'm going to get rid of this minus 2, and I do the opposite, plus 2 to get rid of it, to cancel, and I do plus 2 here. So once I move that around, what's 9 minus 5? 4y. And then I have left here 14 plus 2, which is 16. And then I just divide by 4. So y is 4. All right, so y is 4, but that's not our answer, because it said what they're asking us for is what's the measure of PQ? 9y minus 2. So to find PQ, it's going to be what? 9 times y, which is 4. We're going to substitute that in, and then minus 2. And then we just work that out. 9 times 4, 36, minus 2, 34. And so it looks like the distance of PQ is 34. No units of measurement, so we won't write that in there. We'll just write 34. PQ is 34. Isn't that fun? Next one. Similar, but notice now we don't know what the two short segments are. We know the whole entire segment. Again, though, the key thing is B is the midpoint. So this is the midpoint, which means what? From A to B has to equal B to C. Well, this time I don't have anything I can add to 2A plus 1. How could I add something together? There's nothing there. If they're equal to each other and BC is 2A minus 1, wouldn't AB also be 2A minus 1? Wouldn't it be the same thing? Doesn't that make sense? Sure. Okay. Well, now that you've got that, now we can kind of do what we did like on our last problem. I can just say 2A minus 1 plus 2A minus 1. If I add those together, it will equal 3A plus 1. It will equal 3A plus 1. So again, I have now written an equation. It was a slightly different twist on what we did before. But basically, again, we know that these two segments have to be equal and add up to be the length of the total one. So before, I could make those equal to each other. This time I have to add those two together to equal the whole one. And now we just solve. Okay, so I've got, let's see, I lost my pen. There it is. 2A and 2A. These two I'm going to add together. Since they're on the same side, I just add them like normal. That's 4A. Minus a negative 1 and a negative 1, that's negative 2. Now I'm going to take this A and combine it with that A. So I'm moving to the opposite side, so I do the opposite thing. It's a positive 3A, so I subtract 3A to cancel. And this is a negative 2, so I do the opposite. To move it to the opposite side, I add 2. 4A minus 3A is 1A. 1 plus 2 is 3. Now, did they ask us what A is? Was that the thing that they were asking for? They said, what's the measure of AC? So again, nope. We solved this. We needed to solve it, but that's not our answer. We have to plug it back in. What are they asking us for? AC. AC is the whole length, so it's this one. So we're going to say AC has to equal 3 times A. We now know that A is 3, so we plug that in. Plus 1, and 3 times 3 is 9, plus 1, which means AC is 10. Again, there's no units of measurement there, so we won't include those. We'll just call it AC is 10. Isn't this kind of fun? These last two are really fun. Okay, last thing, very last thing, and then we're done. Just really quickly here, remember last lesson, we've been talking about, in the last couple of lessons here, midpoints. Especially today, we've been talking about midpoints a lot. I think we talked about a bisector previous. I think we used that word previously, but a bisector, basically, anytime you see that word bisector, it means it splits something in half, okay? And so in this case, a segment bisector is something, or a line, a segment, a line, or a plane that splits or intersects a segment at the midpoint. So like if I have, for example, here's a line, or yeah, that's fine. I'll draw a line and I'll make a segment on it. Okay, so here's AB. So we've got segment AB, right? If I drew a line, this looks like it's probably about the midpoint right here. That's about the midpoint right there. If I drew another line that went through that, like, and this was the midpoint here, I'll call it M. This line would be considered a segment bisector because it bisected or split AB into two equal parts right at the midpoint. So whatever that is, whenever you see that word segment bisector, It's another segment. It could be a line, or it could be a plane even, that splits a segment, in this case AB, right at its midpoint. That's it. Okay. Good job, guys. Hope you enjoyed it. This is Mr. Anderson. Until next time, we'll see you later.